Okay, so we're on to number 11. Given that y is inversely proportional to x, okay, so automatically that means that y is inversely proportional to 1 over x. And when you put that into an equation, it means y is equal to k times 1 over x. And then they tell you that y is 4 when x is 3. So what you have to do from this equation, you have to substitute y is 4, so 4 is equal to k times 1 over 3. And then rearrange it to find k. So what I'm going to do is to times both sides by 3. So 12 will be equal to k, because 1/3 times 3 is 1, and the 4 times 3 is 12. So if k is equal to 12, find an expression for y in terms of x, go back to this equation. So y is equal to 12 times 1 over x, which is a good answer. Or you can write it as y equal to 12 over x, whichever one you prefer. So because we know that y is equal to 12 over x, you've now got to use that information to find the missing values. So I'm going to find this one first, and that's when x, we're finding out x, and we know that y is 1/5. Okay, so because y is 1/5, you've got to substitute into the equation. So 1/5 is equal to 12 over x, okay, which is the same as 0.2 equals 12 over x. Now, this triangle is so powerful, 0.2 is 12 over x, so x is 12 divided by 0.2, which would be 60. So that's definitely 60 there. If I'm working this value out, that's when x is 0.25. So x is 0.25. If you substitute into the formula, y is 12 divided by 0.25. That's your x value. So that would give you 48. Okay, so that answer is there. So it's always a case of what am I working out, so that you know then where to substitute into the formula. Question number 12, express as a single fraction in its simplest form. Okay, so the first thing you need to do is to find out the lowest common multiple of the denominator. Now, if you've got 3x plus 2 and 2x plus 7, that would be the smallest expression that it would divide into. So you're just basically putting them together. I put brackets in to separate them. Okay, so to work out the denominator, what you have to do, how many times does 3x plus 2 divide into this expression? Well, it'll divide in 2x plus 7 times. And what you have to do is times it by the top. So 3x times 2x plus 7 minus, how many times does this divide into this denominator? Will be 3x plus 2. Because they multiply, it'll divide in and it'll be 3x plus 2. But don't forget, you've got a 2x outside. So 2x times 3x plus 2. And then what you need to do is simplify the numerator. So by multiplying out, okay, 3x times 2x will be 6x squared plus 3x times 7 is 21x minus 2x times 3x is 6x squared. And be careful here, the minus and the plus will be minus 4x. The denominator stays the same. You can't do anything with that. Okay, and what happens on the top, the 6x squared and minus 6x squared cancels out, and the plus 21x minus 14x will give me 17x. So your final answer is 17x over 3x plus 2, 2x plus 7. Okay, just before I move on to the next answer, some people do it by cross multiplying, and if you look at the first part of it, what we've actually done is the 3x times the 2x minus 7, okay, plus 7, sorry, and then take away the 2x times the 3x plus 2. That's what you end up with on the numerator, and the denominator obviously is the same. Right, question 13. Allied has 3 concrete slabs. 2 of the slabs are square with each side of length x meters. So I need to do a diagram for that. So 2 of my slabs are square and the sides are x meters. Okay, the third slab is a rectangle which measures 1 meter by x plus 1 meters. I think a diagram can help you here. And then it says the 3 concrete slab cover an area of 7 meters squared. So basically, when you work out the area of each one and add them together, the answer is 7. Okay, so the area of this length times width will be x times x, which is x squared. For the same reason, this will be x squared, and for the rectangle, x plus 1 times 1 is equal to x plus 1. Okay, remember x plus 1 times 1 will be equal to that, but it's all equal to 7. Okay, so what you've got to do, you've got to simplify the x squared and the x squared, which is 2x squared. Then you've got plus x plus 1 equal to 7. Now, if you've got to show something, we need naught after the equal sign. So to make this naught, I'm going to take away 7, which means I've got to take away 7 on this side as well. Whatever you do on one side, you've got to do on the other side. So you're left with 2x squared plus x minus 6 equal to naught. And that's exactly what we have to show. So as requested, it is only worth 1 mark. It seems like a lot of work for that, okay? So then you've got to solve the equation that you've just got, okay? So the equation was 2x squared plus x minus 6 equal to naught, okay? You can factorize and you get 2 brackets. You'll get 2x minus 3 and x plus 2 equal to naught. Because remember, you need numbers that add to give me plus 1 and multiply to give me minus 6. And the minus 3 and the plus 2 will give me the minus 6. Okay? Now, that's factorising. When you've got to solve, one of these brackets must be 0. So either 2x minus 3 is 0, or x plus 2 is 0. And at that point, if you want to keep the bracket in, you can. You don't have to. It's just showing you where it's come from in the factorisation part, okay? Now, for this to be equal to 0, that means that 2x must be worth 3. And if 2x is 3, x is 1.5. Or, for this to be 0, x must be minus 2. Okay? Now, in the context of the question, because you've got to justify any decisions that you make, the value of x must be 1.5 centimetres, because you can't get minus 2 centimetres as a measurement of length. Okay, so that would be your answer. Okay, question number 14. Okay, the diagram shows a sketch of the graph y equal to f of x. The graph passes through the point minus 1 naught, so that's significant, and then you 5 naught, and the maximum point, or the highest point, is 2, 7. Okay, sketch the graph of y equal to f of x minus 3 on the axis below. Now, this type of question, the minus 3 actually means that it's translated to the right. So it's a translation 3 to the right. Okay, so in the diagram, I'm going to draw it on here. You could have done it on the original, but they've actually given you the axes to do it. So I'm just going to do a quick sketch of the original, something like that, where that's 5 naught. That's minus 1 naught, and that's 2, 7. So that's exactly as it is on the one above. But if it's shifting 3 to the right, I'm going to do a dotted line for this. Okay, so if I start with the minus 1 naught, if it's moved over 3, minus 1 add 3 will give me 2. So that's going to be 2 naught. Okay, I've circled it, but I suppose it should be in brackets because they're coordinates. And then your 5 naught will have moved to 8 naught. Okay, for the same reason, the 5 plus 3. Okay, but the coordinates of the highest or lowest point, well, instead of 2, 7, I'm going to add on 3 to the 2, and that's going to give me 5, 7. Okay, just a reminder, because it's a translation to the right, it's actually a translation in x, and if you notice, the values that have changed in each one are the x coordinate. Question 14b, using the axes below, sketch the graph of y equal to cos x plus 1 for values of x from 0 to 360. So the first thing you should do, if that's 0, you need to label this 0, 360, halfway is 180, then do your 90, and then do your 270 to split it up into 4. Okay, now what's important with the cos graph is that the cos of 0 is 1. So what I'm going to do, I'm going to draw the cos graph first. Okay, the cos of 90 is 0. Cos of 180 is minus 1. Okay, cos. Okay, so to pick up from question 14b, using the axes below, sketch the graph of y equal to cos x plus 1 for values of x from 0 to 360. So first of all, you've got your naught, put your 360 in, then put your 180 in, your 90 degrees, and then 270. So it's always important having those 4 key markers, okay? So basically, because they want you to do the cos of x plus 1, I'm just going to show you the graph of y equal to cos of x first of all. Now the cos of naught is 1. The cos of 90 is naught. The cos of 180 is minus 1. The cos of 270 is naught. And the cos of 360 is 1. So that's your graph of y equal, and again, it takes a bit of practice drawing it up. That's y equal to cos of x. I'm just going to label that there. Okay. Now, if you want the graph of y equal to cos of x plus 1, that's a vertical shift of plus 1. So all I'm going to do is add on 1 to these points. So 1 becomes 2. This naught will become 1. This minus 1 will become naught. Naught will become 1. And then again, 1 will become 2. So the graph of y equal to cos of x plus 1, oh dear, would be something like that. So that's your y equal to cos of x plus 1. Remember, it's a shift in the direction, plus 1 vertical. Question 15, simplify. Now that looks really, really complicated, okay? But what we're going to do, we're going to take each part of it in turn, okay? So for the 5 root 3 squared, that's the same as 5 root 3 times 5 root 3, which if you simplify, you could make it, you could put the 5's together, you can put the root 3's together. Either way, that's 25, that's 3, so that's 75. Okay, so we've worked that out to be 75. I'm now going to work out this term here. Okay, now 2 root 18 divide by root 2. Now, to get rid of the third in the denominator, you have to rationalise it. And what that means is times everything by root 2, the top and the bottom. And the reason you do that is because these will give you 2. And on the top, you'll end up with 2 root 18 root 2. Which is equal to 2 root 36. And because the square root of 36 is 6, and they cancel out, the answer to that is going to be 6. Okay, so just to recap, the 2's will cancel out. The root 18 root 2 is root 36, so that's going to give me 6. So that's 6 there with the minus in between. On the denominator, root 32 times root 2 is the same as root 64, which is 8. So the answer to that is 8. So let's see, let's put it back in, okay? So you end up with 75 minus 6 all over 8. Which is 69 over 8, which is definitely rational because it's expressed as a fraction. Question 16, the question on probability. A game played at a children's party involved throwing a ball into a bucket. Each child tries to get the ball into the bucket in the least number of throws. On each attempt, the probability that Sophia gets the ball into the bucket is 0.8. Each attempt is independent of any previous attempt. Show that she is 5 times more likely to get the ball into the bucket on her first attempt than to have her first successful throw on her second attempt. Okay, so if you look at the first bit of information, probability that she gets in the bucket on the first attempt is 0.8. The probability that she gets it on her second attempt okay, what does it actually mean? Well, it means the first attempt she misses, and the second attempt it goes in the bucket, okay? So if you like, it hits. So first attempt misses, if it goes in is 0.8, that must be 0.2, because it'll either go in or it won't go in. And the second attempt will still be the 0.8. So when you work out the answer, you'll get 0.16. Now, 0.16, okay, times 5 is actually 0.8, which is the probability of her getting it in on the first attempt. So go back to the question, show that she is 5 times more likely to get the ball into the bucket on her first attempt. Well, we've shown that because 0.8 is a result of 5 times the 0.16. Okay? Thank you.